Hi everyone, I'm going to show you a couple things to start. For instance, when people are having a hard time finding files or pictures, if you go to our Canvas site, you can actually go over here, click on Files, click on Date Modified, Causation Venom, and you will actually get all the pictures and things I put up if they're not clicking when you're on an assignment. Now, I'm going to post the notes. Please pay attention to these notes. This week is a quiz. Next week is going to be a test on chapters 3, 4, 5, and 6. I want you to kind of pay attention to the notes I put up and watch these videos because they're going to give you a little more insight into exactly what I'm looking for. So if we were in class, I would actually draw out this picture. So we're talking about price, elasticity of demand, the quantity demanded towards price change. But there's a really weird thing happening on this graph. Now, I've mentioned before that in older units, I said that there are these four types of graphs: slope, gradual, very steep slopes, which use the gradual slope would be elastic and the quick one would be inelastic. And then the zero slope, undefined slope. And we went through that when I showed you these, and we go through zero, positive, negative, and then we went through elasticity and what elasticity, this steeper slope, would change it from being less elastic, we call it inelastic, and this one's more elastic. So now that we've talked about elastic, having a slope of 1/2, less elastic being like 5 slope, 5x plus b. We're going to go back to the notes for this week. So in the notes, this says in this one graph, which I'm going to show you in a second, it says it's elastic up here, but inelastic, but the slope never changed. What they're referring to is this midpoint here, and then they use percentage to find the difference. Whereas when I look at these, the difference between here to here, the slope is the same as here to here, but they use percentages. And then a graph within a graph is another concept. This graph within the graph actually manipulate, as one graph is changing, this graph is actually changing as well. They have an effect on each other. That's why there's a dotted line all the way down. So I'm going to show you how to build this, and I'm going to show you what this really means. And what this really means is you actually in math can have a graph affect another graph. So let's bring up what I'm talking about using this picture. This is a picture of actual coordinates being graphed. And as these are being graphed, it's manipulating what's actually happening over here. So these are all the coordinates these are being graphed with. So as you go across on this graph, it manipulates and moves the entire curve for this graph up. All they're doing is testing coordinates on a separate rate graph, and it affects the change in population over here. This is a normal mapping. It's a little confusing, but it actually makes sense, and that's what the graph is doing. So let's go back, and I'll show you. This is the lesson I would have normally taught. Okay, so what he's saying here is a $10 change when the original is when you're going from 10 to 20. It's not as big of a change percentage-wise. So this is actually combining percentages with graphing, which is it's typically not done in algebra, but it's very common when we talk about price elasticity, which is why this slope looks the same, and this slope looks the same, but the slope of this, because the percentages are bigger and these percentages are smaller, you now can quantify and say that this one is elastic because it's not as big a change from 10 to 20, but there's a bigger change from 90 to 80. So let's look now at the rest of the work. So we have perfect elastic demand curve, horizontal zero slope increases, quantity of demand to zero. Perfect inelastic curve is an undefined slope. The price changes no change, and we have the graphs to show for this. They have the graphs right in the book. They explain it to you very well, but there's one thing I want to show you is here is perfectly elastic, perfectly inelastic, and unit elasticity. So you can see unit elasticity goes up one at a time. They're going to refer to that a lot in this book. So perfect elastic is flat horizontal, perfectly inelastic is straight up and down. Same idea, slope is zero. This is a high slope. It could be it's very close to being like a slope of 10 or 20. So let's go down to elastic supply. Same thing. Elastic supply is a price change, large effect on supply. Inelastic supply, little change on supply. Perfect elastic supply curve has a slope of zero. Perfectly inelastic supply curve is straight up and down. I like these examples of real life. So if you were watching the graph of this, what would be an example? An example would be not everyone is going to buy carrots at the prevailing current price just because you do. So if you buy a carrot here, not everybody's going to buy it at that same price. This is a really good example, the Elvis Cadillac example. So this is a supermarket example, a flat line. That's why you go to a supermarket, because you may want to spend $5 on a cat. You'd spend $5 on carrots, but not everyone will. And because of that, you don't typically have different prices. You don't have different prices for the same product in a supermarket. They're all the same price. It's called economies of scale, which comes up later too. But this, look how it goes up over time. It just keeps going and going and going and going. The product's not changing, but that's more like a vintage car. So right here, the price inelasticity, straight up and down, is perfectly inelastic. Elvis's Cadillac, so like a vintage car goes up over time. Maybe houses would apply to this as long as there's not a housing crisis. But things that go up consistently over time, memorabilia, stuff like that. So unit elastic. So let's talk about the last part today, which is supply become more elastic. So over time, typically, this is again always in a perfect world when nothing changes. But over time, if you have something and the supply of something is going straight up and down here, over time, after a week, after a month, after a year, supplies typically become more elastic. You can go up and down the prices easier. Uh, so there's a lot of great examples of this in your book. I'm just thinking of things off the top of my head, but you can always come up with things that as you know it long enough, there's a lot of more easier ways for you to change the prices. So chapter six is the consumer demand. You have to learn this thing called utility. Utility is the unit of increase of happiness or value or satisfaction, pleasure you get from something. This is a legitimate thing. So like olfactory is a unit of smell. Centimeters, meters, miles per hour. All these things are measuring tools. So measuring units. Utility is actually a unit to measure pleasure and satisfaction. That might be a question on the quiz as well. Marginal. This is really important. So marginal means you go up every time you go up one, there's an effect. So this total utility. This is just a graph of utility over marginal utility. So after 1 week, it's 40 total. 40 went up from 40. It's 40. 2 weeks is 68, but it's not 68 is not the amount it went up total. It's the total now. So it went up 28. So you can now calculate using simple fractions. You can now calculate the marginal unit per dollar. So as they go up 20, but it only went up 20. What happens once it hits 5? After 5 weeks, it doesn't go up. eventually it starts going up, and it's not going up by the same amount. It's not positive anymore. So you can actually start coming up with ideas of things. What goes up marginally, utility, supply was marginal increases that can eventually hurt you when you go up too much. The perfect example is from there was a movie about McDonald's, and they purposely went to a tennis court because they only had a certain amount of square footage in a store, and they built the store. So they didn't just keep hiring people. Oh, well, let's just keep hiring people to make hamburgers, keep hiring people. No, there's a marginal increase, and eventually, if you keep hiring people, you'll lose money. They'll be tripping over themselves. So they tried to figure out the exact right place for every single machine and every single thing that goes into a kitchen. And that is how you maximize um, and get more out of each increment. So law of diminishing marginal utility or diminishing return of any type of marginal, anything marginal. So we're talking more of a person consumes a good, the smaller increase towards total satisfaction. Water, food. So if you drink a ton of water after you run a race, the first sip tastes great. You get a lot of satisfaction. But after like the fifth sip, you're not even getting any satisfaction. You're already fine. There's a certain amount where you hit your amount that you no longer need any. This is a good graph of utility. It's the most modern. This is the most modern use of utility and how people measure it. When you get bad things happen to you, it affects you a lot faster than good things. But I'll go back to that graph over and over again throughout the year. Consumer equilibrium, know what a consumer equilibrium is, and then the consumer surplus. I budgeted to pay $800 to fix my car. It only cost 600. The surplus is 200.